What if every car was electric, starting tomorrow morning? No tailpipes, no engine rumble, just battery packs, power electronics, and the grid holding the whole show together. Sounds simple. It isn't. Systems hate sudden change, and the grid takes everything personally. Today we'll trace the cascade. Energy, economics, infrastructure, and people. Without the hype, just the wiring. There are roughly 1.4 to 1.5 billion passenger vehicles worldwide, with internal combustion engines dominating today's fleet. Road transport consumes about a quarter of global oil demand. Refineries, pipelines, tankers, and filling stations form a century-old distribution system optimized to the minute. It's robust, not flexible. Electric grids balance supply and demand in real time using generation mixes that vary by region. Coal, gas, hydro, nuclear, wind, solar. Margins are tight in peak hours. An EV is a battery, a motor, and power electronics governed by software. It's efficient, around 3 times more energy to wheels than gasoline. But electricity must arrive precisely when people plug in. Daily mobility is spiky. Morning departures and evening returns with clusters around workplaces and suburbs. That spike matters. Households spend materially on fuel. Switching to electricity changes the cash flows, not the need to travel. The question is where the strain shows up first. Urban apartments, suburban garages, and rural properties have very different charging realities. Parking decides more than ideology. Baseline set. Lots of cars, constrained grids, entrenched fuel logistics, and consumers who just want their commute to work. Now, flip the fleet. If every car were electric, immediate electricity demand would rise sharply, but not all at once, most charging clusters in evening hours. Without controls, local peaks overload distribution transformers first. A cul-de-sac with 10 homes and 8 EVs plugging in at 6 p.m. can exceed transformer nameplate ratings by 2 to 3x. Utilities would push emergency managed charging, staggered starts, lower currents, and time-of-use pricing immediately. Multi-unit dwellings face circuit capacity constraints. Load-sharing EVSes rotate access to avoid breaker trips. With incomplete home charging, drivers flood DC fast sites, creating queues that resemble weekend fuel lines. Operators throttle chargers to protect site transformers. Gasoline demand collapses in days, not years. Refineries cannot pivot that fast without losing margin. Storage fills, crack spreads invert, and operators cut runs. Some refineries idle units temporarily. Diesel remains for trucks and heavy equipment, stabilizing parts of the complex, but the gasoline slate still hurts. Oil producers face revenue shocks. Global trade routes reprice. Currencies tied to hydrocarbons wobble. Households see fuel line items vanish and electric bills rise. Total cost per mile drops, but only if charging is mostly off-peak. Peak charging wipes out savings quickly. Workplace charging becomes prized real estate. Employers deploy load-managed Level 2 to attract staff. Rural drivers benefit from home overnight charging but face sparse DC fast coverage on cross-country routes. Cold weather range loss and cabin heating draw require planning. Preconditioning becomes common behavior. Maintenance shifts. Fewer oil changes, more tire rotations. Regenerative braking cuts pad wear, but not tire physics. Day-ahead power markets reflect new evening ramps. Gas peakers see more dispatch, while solar-heavy grids push charging past midnight. Night wind smooths some regions. Smart charging soaks it up if utilities can signal drivers and aggregators. Thermal limits on feeders and transformers are the hard stop. Utilities accelerate reconductoring and transformer swaps. Home solar helps daytime, less so evenings without storage. Midday workplace charging harvests, surplus PV. Large commercial loads curtail briefly during EV peaks. Flexible loads like data centers and cold storage monetize demand response. Ambient city noise drops. Low-frequency engine roar declines, but tire and wind noise remain. Pedestrian safety shifts to acoustic alerts at low speed. Regulations require minimum sound signatures. Battery manufacturing scrambles to expand. Supply chains for lithium, nickel, graphite, and sodium alternatives get stress tested. Tailpipe emissions go to zero immediately. Life cycle emissions depend on grid mix and manufacturing footprints. Coal-heavy regions see smaller near-term net reductions. Gas and nuclear regions do better. Renewables plus managed charging do best. Urban NOx and PM 2.5 from exhaust fall sharply. Tire and road dust persist, but are less toxic than combustion aerosols. Reduced tailpipe pollution lowers asthma exacerbations and cardiovascular incidents over time. Noise pollution declines modestly at low speeds. Highways remain dominated by tire noise. Energy cost per mile falls in most regions, especially with overnight rates. Price volatility shifts from oil to electricity markets. Utilities invest heavily in distribution upgrades, substation capacity, and smart meters, financed through rates and incentives. Workforces transition from refining and fuel retail to electrical trades, charging operations, and software services. Fuel stations retrofit with chargers, food services, and restrooms. Dwell time economics replace throughput economics. Oil prices fall on demand shock, then stabilize at lower equilibrium. Petrostate budgets adjust with lag. Automakers consolidate platforms around motors and battery packs. Software and power electronics gain margin share. Distribution transformers get upsized to handle clustered EV loads. Utilities standardize on higher kVA replacements. Curbside Level 2 rolls out in dense cities using streetlight circuits and pedestal units, coordinated with parking policy. Networked EVs allocate amps across vehicles, prioritizing departure times and rates while staying under main service limits. Battery storage buffers evening peaks. 1 to 2 hour systems defer feeder upgrades and arbitrage wholesale prices. Generation additions skew to solar, wind, and firming resources. Interconnection queues bottleneck timelines. Aggregators enroll millions of vehicles, shifting load away from peaks with simple incentives, cheaper rates, and default schedules. Bidirectional pilots expand, but large-scale V2G adoption remains limited by interconnection rules, warranty terms, and metering complexity. Bus and truck depots deploy megawatt-scale chargers with on-site substations and storage. Scheduling software is essential. Battery materials scale via diversified sources: brines, hard rock, and recycling. Sodium-ion enters for lower-cost segments. End-of-life packs feed hydrometallurgical lines. Recovered nickel, cobalt, and lithium reduce primary mining intensity. The drive experience is quieter and quicker. Most drivers adapt within days, and then never want to see a gas pump again. Equity challenges surface. Drivers without home parking face higher costs and time penalties. Public chargers must be reliable, well-lit, and safe. Workforce training expands for electricians, line workers, and software technicians. Certifications standardize practices. Insurance models adjust to repair costs of power electronics and bodywork. Lifetime risk curves shift with ADAS penetration. Cities revisit parking policy, allocating curb space and updating building codes for EV readiness in new construction. Rural co-ops prioritize transformer upgrades and smart meter rollouts, coordinating with member co-ops for funding. Trade flows pivot toward batteries, semiconductors, and high-voltage harnesses. Ports adjust to different cargo profiles. Cross-border electricity trade increases to balance renewable variability. Interties gain strategic value. National inventories shift from transport to power sectors. Regulators tighten grid emissions intensity targets. Critical minerals markets get volatile, then stabilize as recycling and alternative chemistries mature. Interoperability becomes non-negotiable. Charging protocols converge to reduce failed sessions and driver frustration. Macroeconomically, transport electrification reduces oil import bills and shifts investment to domestic grids and manufacturing. Reliability metrics stabilize after the first upgrade wave. Managed charging becomes as normal as a thermostat. Apps default to off-peak schedules, with exceptions for trips. Friction drops when defaults are competent. Cities look the same. They just smell less like benzene. Progress without spectacle is still progress. 5 years in, EV load is routine. Off-peak charging has flattened the classical evening peak in many regions. Distribution networks run thicker conductors and higher capacity transformers. Fault detection and sectionalizing are smarter. Generation mixes skew greener with firming from storage, hydro, nuclear, and gas with CCS where economical. Second life EV packs serve in stationary applications where power density matters less than cost. Recycling closes material loops, reducing upstream mining intensity and geopolitical risk. Traffic volumes don't magically vanish. Mode shifts happen at the margin when transit is reliable and safe. The curb is a battlefield of chargers, deliveries, and micro-mobility. Cities iterate with data rather than slogans. New buildings wire a share of stalls for EVs. Retrofit funds target older stock gradually. Highway stops monetize longer dwell. Restrooms, food, Wi-Fi, and safe lighting, a basic idea that should have existed anyway. Fleets run on dispatch software that blends routing with energy planning. Downtime shrinks. Rates evolve. Dynamic pricing for flexibility, protections for essential mobility, and baseline allowances for equity. Uptime targets enforce maintenance discipline. Payment and authentication work because standards finally do. Repair networks specialize in high-voltage systems and body structures. Insurers price accordingly as data accumulates. Energy security improves as transport fuel shifts to domestic electricity. Exposure to oil shocks declines. Resilience planning includes mobile storage and microgrids. Evacuation routes feature charging under backup power. Health gains accrue quietly. Streets become less sooty and slightly less noisy. Progress by subtraction. Chemistry evolves. High manganese, LFP, sodium ion for cost and durability, silicon blends for fast charge within safety envelopes. Edge cases remain. Winter road trips, rural coverage, grid outages. Solving them is logistics, not magic. In the long term, an all-electric fleet is workable, cleaner, and cheaper to run, if the wires, software, and people keep up. The future doesn't arrive with fireworks. It arrives with schedules, standards, and upgrades. Boring is underrated, and the grid, once a backstage actor, becomes the main character you never notice, which is the point. Electrifying every car is less a revolution than a project plan. Fortunately, project plans can be managed. And now we know where the pinch points are and how to unpinch them. Here's the through line. Environmental gains scale with the grid. Economics favor off-peak behavior. Infrastructure defines the pace, and people define the defaults. Small habits matter. Scheduled charging, reliable public sites, and realistic road trip planning. Behind the scenes, crews swap transformers, software reroutes load, and storage shaves peaks. Money flows from imported fuel to local electrons, from oil logistics to grid logistics. And the air gets cleaner, quietly, one evening at a time. Globally, the transformation harmonizes with grids, materials, and trade. The awkward phase is temporary, the benefits persistent. So what if every car was electric? It's doable, not magical. A coordination problem we solve with wiring, software, and patience. Practical beats dramatic. What scenario should we explore next? Share your ideas below. You've been watching IfVerse, where imagination meets possibility. See you in our next reality. What scenario should we explore next? Share your ideas below.